I've called this circular cities, which might be a lie, but we'll see. Um, so I'm just going to throw out several thoughts about circularity, which I hope will connect up. So this first one is looking, and I was interested in Teresa reminding me of the three principles of circularity from the Ellen MacArthur Foundation, because I was interested that none of them actually refer to environmental impact, which I think is fairly fundamental. And for those of you familiar with the Ellen MacArthur Foundation, the MCI is the Material Circularity Index, and at the moment that seems to be the focus. So a high number of 1 is good and a low of 0 is not so good. And what this is comparing is three sources of a product. One is coming from Inverness, one's coming from Manchester, and the third one's around the corner in London. And of course, if you take the current definition of which is best, you're going to be going for the MCI of 1, but in fact, because that's 570 miles away, actually that's about the worst. And if I show you this diagram, so this is looking at recycled aggregate transported 10 kilometers, the same transported 70 kilometers, virgin aggregate 10 kilometers, virgin aggregate 70 kilometers. And you can see here that actually the recycled aggregate transported 70 kilometers is a lot worse than the virgin aggregate transported 10 kilometers. And the circularity bit, or the recycled carbon impact, is the blue. So it's not just about circularity, it is about the context in which something is circular is being used. And I think that's a really important point. So what I'm saying here is that yes, it's circularity, but yes, you should also be looking at the environmental impact, and particularly the global warming potential, I suggest, which is capable of a degree of measurement. So if you look at this diagram, this represents the RICS, this comes out of the RICS professional statement. It's also the standard EN 15978, and shows the life cycle stages of a project, from the product, construction, in use, end of life, and reuse, recovery, and recycling. And all those things in the red box represent a CO2 cost, but the potential for reuse, recovery, and recycling represents the potential benefit, which is the circular bit. And so, as you can see on the green arrows, the potential for waste from all of those stages can also, of course, be used, reused, can be recycled if it's designed appropriately. And in a sense, what this is saying is that the BRICS document is actually a way of measuring circularity, which has an environmental aspect to it. It's not just about whether it's circular or not very circular, it's about what is the environmental impact of that circularity. So to give you a kind of example, this is looking at bricks, and this is looking at going from an existing building to a new building, and then what happens if you go on to the next generation of building not yet designed or thought about. And if we look at it like this, that when you demolish a building, you can either have rubble at the bottom there, or you can pull it apart more carefully, and you get your bricks, and the yellow line around the bricks is representing a lime mortar. So those are the sort of, if you like, the basic options. But of course, if we're going to reuse those bricks, we've got to compare them with a new brick, and to clean up a brick from an existing building costs you more than a new brick, which is obviously not very satisfactory. But there is the Social Value Act. Now, the Social Value Act, which I'm not an expert in by any means, but what it can do is it can, by employing people who are otherwise sticking knives into people, you can get a credit against your Section 106 agreement, and that would enable you to employ somebody to clean up your bricks. So from that perspective, and that's probably a simplification, but you get the gist. But what that means, of course, is your new bricks and your recycled bricks are now equivalent in cost. And also there's a social benefit. So let's say we're going to go for the recycled brick route because that's better. We've now got a choice between cement mortar, which is what we typically do now, or lime mortar. And putting aside the environmental impacts of cement versus lime mortar for a moment, which one would you go for? Well, of course, if you go for the lime mortar, then you can recycle the building and recycle the brick in the future, and you can keep on going round with just the lime being removed. Whereas, of course, if you go for cement, you can't do that. But there are other aspects to this, and this is one of the things. One of my clients is Grosvenor, and I've been trying to convince them into engaging with the circular process. But there are a lot of issues that you have to deal with. So, apart from that issue I've just described, what about the numbers? So, on the bottom here, just say you need 10,000 bricks, and what's available is either 8,000 or 11,000. So, it's unlikely to be precisely the required number, which means you've either got a waste or a shortfall, which has costs and implications. There's availability. They may be available on the 1st of May, but you need them on the 1st of July. What happens in the meantime? And again, that has issues and implications. And finally, there's is information about those bricks. What is the color? Does it match what you want? What is the strength? What is the condition of them? So all of those things are sort of issues that you have to combat with dealing with a sort of simple circular notion. But I think the answers are, in a kind of way, and they've already been sort of mentioned. At the top, I've got retention and retrofit. There's nothing better than keeping the whole building and reusing the whole building and retrofitting it. That must be a good starting point. The other thing is standardization. If we've got, and data, which is, if we have standard components for buildings like, steel beams are, say, 7.5 meters, because that's the standard grid, well then clearly the reusability of them is greater, and you don't have to chop bits off them or compromise your design. So standardization and information about that. At Broadgate, British Land were able to reuse an entire structure for the simple reason that they had data about the loading on those steel sections. If they hadn't had the data, the engineers' PI would not have covered the reuse of that structure. And then finally, durability and disassembly. And durability ties back into retention and retrofit. And disassembly, the ability to disassemble a building and reuse it to the max, is obviously another sort of circular attribute. So I'm going to show you one project that I was working on. This is for Gatwick Airport. And we were asked to, well, what we proposed to them was producing a GIS map, Geographical Information System map, of the entire airport. So what you're looking at here is a carbon map of the airport. So every polygon on this map has a spreadsheet behind it, which tells you all the data that we could collect or by viewing the site assemble. So in this spreadsheet here, we've got carbon data, we've got what the thing's made of, steel, concrete, etc. And that enabled us to, for a new capital project, so for example here they were talking about a new terminal building, what we were able to do is, by using this map, is actually, because there were other projects going on, which are minor projects, is figure out whether we could reuse and what the carbon benefits of that, of the sort of circular process of reusing those onto the new project. What we also did was work with the architects who were designing the new terminal, and they were rethinking their design so that this building could be dismantled and reused, because obviously one thing about airports is they never stop changing, and they keep on changing the buildings, adding bits and all the rest of it. So the idea was to produce this as a sort of carbon and circular process. And obviously this is not a city, but you sort of get the idea. And of course the interesting thing is that Gatwick saw this as actually saving money. So this is, people tend to see sustainability as a costly add-on. Actually this is all about reducing costs. Oh, okay, that's all right. So this is you'll be pleased to hear my last slide. So what I'm suggesting is if you take that GIS map and apply it to a city, and bearing in mind that this is a Google Earth map, so as we know, Google has produced this kind of level of detail on just about every street on the planet, which is a phenomenal amount of information and investigation. So if you think about that, why is it not possible, or it surely must be possible, to map all building material data in much the same way, creating an inventory of the environmental impacts of all this stuff, rather like the carbon map of Gatwick. And there's no reason then why you can't create a virtual circularity market, so that you actually can start to share that information all over the the city or further afield, but certainly you could then track and things like the numbers of bricks you could sort out because you could move them around. So this is moving on, if you like, from, but of course you'd need the passport, you need the material passports. So there we are, that's the end of my thing, and if you're really into it, my book's available in the bookshop.